Hey friends, welcome to another video of training. Today's video is a lot longer than other videos, but I can almost guarantee you, if you watch every single minute of today's video, you will learn what an economizer does and how to troubleshoot one. So I want to start off by saying that this training panel was built by my colleague, whom I consider as my mentor. All credit goes to him, but that's good for you guys because that allows me to train you guys using this economizer training panel. So what is an economizer? Simply put, it's free cooling. Let's say it's a cold day. And so normally on a cold day, your house is also going to be cold. You're probably going to use heating. You're probably not going to need to turn on the air conditioning equipment. You're not going to have a call for cooling. But let's say it is cold outside and you have 30 kids in a classroom, or maybe you're baking, maybe you're having a lot of people over. You're probably going to have a call for cooling because your thermostat is going to pick up that heat and it's going to call for cooling. But with an economizer, you're able to bring in that outside air in that is cold without turning on the compressor. And I'll repeat it again. With an economizer, and if you have a call for cooling on a cold day, it's not going to allow the compressor to turn on, and instead it's going to bring in that nice cold outside air to cool down your house. And we have a couple of things that we're going to bring out in this panel. It's going to be this actuator, this Jade controller or economizer controller, our thermostat, and this contactor. And this contactor, you can compare it to the compressor, because if it receives 24 volts, it sends power, turns on the compressor, now we get cooling. And also a damper. And what is a damper? Well, right here you see a damper. And so this normally is what gets installed outside so that we can bring in some nice cold outside air in. And simply all you're doing with the damper, you have a shaft right here coming out and you have damper. So right now it's in the closed position, but I can actually manipulate it so I can open it. You see, now it's 100% open. That's about 50% open, and now it's closed. And so you'll see in a video where we're going to be talking about the actuator, how the actuator controls this damper. But I just want you to see what a damper is. You're just opening or closing to allow that nice cold outside air to come into the house. Okay, so before we go into installing an actuator, I'm going to just show you what a thermostat does when we have a call for cooling. So it's pretty cool how it's laid out here. If we have a call for cooling, this yellow light is going to turn on. But what I did, just so that you guys can see, I ended up connecting. So if you follow these two yellow wires, this is my 24 volts, right? So the bottom one is my common, that's my hot, my 24 volts. So what I did with my common, I went straight to this side of the contactor coil. So my common is already going home run to my contactor coil. All I need is my 24 volts coming to this side of the contactor coil. And I already have the wire, the alligator clip, right here on the Y1, right? Because if I were to do this, right, you see that's straight 24 volts, but the compressor is going to stay on all the time. So that's why you put it on the action. So when we have a call for cooling, it sends 24 volts out. But when on a typical straight cooling system, when we do have a call for cooling, this is all we're doing. So let's say we have a call for cooling, okay? And look at that light turn on right now. Boom. And then I just heard the contactor coil receive 24 volts and pull in, right? So, this, with the system that does not have an economizer, my 24 volts goes straight to the contactor to turn on the compressor. But with a system that has an economizer, let's say, we have a call for cooling. Before the action, the yellow wire, the Y1, the yellow wire, the call for cooling, before it goes to the contactor coil, right, to power up the contactor coil, it is going here first on a system with an economizer. It's going right here to Y1-I, and that's the call for cooling, Y. The I stands for in, and then Y1-O means out. So yeah, when I have a call for cooling, that action, the yellow wire, is coming in here, and then it comes out. And then when it comes out on Y1-O, then it goes to my contactor coil. So just to do a little recap, it doesn't go when you have a system without an economizer. It just goes straight to the contactor coil. But with an economizer, it goes to Y1 in, Y1 in, boom, and then Y1 out. And whether it goes to Y1 out depends if the controller is in an economizer mode or not, which we will see a little later on in a video. Okay, so the first step is installing the actuator correctly. You don't know how many times I've gone to a unit and these are on the floor, they never get installed properly, and if they're not installed properly, then there's no way that the economizer is gonna work correctly. So first thing is finding out if it's gonna open clockwise or counterclockwise. So the way it is right now, let's see if it opens clockwise or counterclockwise. So if I try to go to the left or counterclockwise, you see it's already closed. I can't open it. As I go clockwise or to the right, you see it opens. So I go to the left, counterclockwise, closed, clockwise, to the right, that opens. So it opens clockwise. So let's go ahead and put that back. So now we have an actuator, we have the bracket, and we have a couple of screws that we're gonna need. So here in the back, you have like a little place where to put the bracket. So when you put it, this is the idea behind it. You see you have a little lip there. So by putting it here, you see there's no way it comes out. So two things. You're putting it first through the shaft, right? So the shaft goes in here, inside here. So you're gonna put that in there like that, right there, okay? And then let's go ahead and push that. I might have to open this up a little bit more. And you gotta just grab onto this bracket because you don't want it to fall. So, okay, so now you go ahead and screw in that bracket into the box. If you can get one in, that's good. You see, now you can use two hands. You don't have to hold anything. So let's go ahead and put this screw here. That's it. Okay, so you see how now that actuator is not going anywhere. But we're not done. We're not quite done yet. We have to now tighten up these nuts so that the actuator can work with the shaft and open or close that damper. So let's go ahead and get our little socket wrench, and with the right socket size. And so all we're doing here, we're gonna go ahead now and tighten up these nuts right here. So let's go ahead and do that right now. And then I did do this too. You have a clutch right here, right? So if you press this the button here, it's a little clutch. You can either go to the left or to the right, left, right. You see, and we did say that this actually the damper opens clockwise. So I'm gonna put it all the way to the left so that when it moves clockwise, you see it's gonna open all the way. So I'm gonna start here on this side. I'm gonna go ahead and tighten up these nuts here. And I like to first do like a hand tighten them, so then it's easier for me to tighten them. So let's go ahead and do that. Okay. All right. So you want to make sure it's pretty tight. Sometimes they can be a little loose, not too much where it's gonna break. You're gonna break it. But all right. So now this is the test you want to do. So that damper, you want to make sure when you press this clutch that when I open it, it's gonna open as I open this one clockwise, right? And I'm not even touching the shaft. I'm gonna be using the actuator. It's gonna open that damper all the way. I'm gonna press the clutch. Okay, let's press the clutch and then open it from the top. You see, and I'm not even touching the shaft. The shaft's already it's already grabbed by the actuator. I already tightened it. But by me manipulating the actual actuator, you see, it opens and closes the damper. So you want to make sure that when it opens it, the actuator is actually gonna open it, right? It's not gonna be free spinning, and that it's gonna open it as you go clockwise. Yeah, there's actuators where it could open counterclockwise, but with this specific one, we already tested it. As I go clockwise, it opened it all the way. So you see, I go clockwise, open, counterclockwise, closed. Okay, so now we're gonna focus on the wiring for an actuator. So we get a closer look up, and just for simplicity, we are gonna use this actuator. I do have a conduit as a shaft, but so we can get a closer look up, we're gonna use this actuator instead of the actuator we were using in the previous clip. But they're basically the same thing. But when you get a closer look up, you look at at least the wiring, the way it should receive power and what power it takes. My black one, simply put, is my ground, my common. My red one is my power, my 24 volts, and my white is my signal. And so going back to this, the black, right, it has a little negative. So my ground, my common, my red, you see it's alternating current, right? That's my 24 volts, right? Common and hot. My white is my signal. And what kind of signal does it receive? It receives a signal of 2 to 10 volts DC signal. So yes, these two here, my common and my hot, that's AC. But then my white one is a DC signal, just like a battery produces a DC signal. And we're not gonna focus so much on the orange wire, but this is my feedback wire. But we're just gonna focus on this one right here. Okay. So when you look at this controller here, and I'll show you right now. So let's go ahead and just first check if we're getting 24 volts. So if you remember, right, the black and red, that's my 24 volts. You're gonna see right there, I'm getting 24 volts, 26 volts, but it's getting power, but nothing is happening to the actual actuator. It needs to receive a signal, right? And we're gonna do a little demonstration right now, but just to really quick show you where it's getting 24 volts from. So the 24 volt, at least in this training panel, it is coming from right there. You see, so this is my source of my 24 volts. So this red wire coming out right here, that's my 24 volts going to my actuator. And this black wire coming out is my common, my ground, going to my actuator, right? Now, if you go to maybe a unit, you'll typically see, instead of it going straight to the 24 volt source, it gets its 24 volts from right here. Actuator common, and then actuator 24 volts, my hot. But just in this training panel, we're getting it right from the transformer, but normally it comes right here. My hot, and then my red and my black wire. Now the signal does have to come here. So you could see it, right? Actuator 2 to 10 volts DC signal. So that white wire right here, this white wire, is going right there to my actuator 2 to 10 volts DC signal. So we're gonna do the little test, but real quick, just to understand the actual DC signal, right? So it's not a 0 to 10 volts DC signal, it is a 2 to 10 volts DC signal. So that means that at 2 volts DC, right? At 2 volts DC, it's not gonna be open at all. It's gonna be 0% open. At 6 volts DC, it's going to be 50% open. At 10 volts DC, which is the maximum, it's going to be 100% open. And then, you can get more specific, 4 volts DC or 8 volts DC, right? What's the in between 6 and 10? It's 8, 75% open. And then 9 volts DC is 87.5. And this is going to matter right now as we do a test. But let's just kind of go back to this. And so let's go ahead and do let's do a test now. Okay. So you can actually, and this is good for you guys to know, because you actually have to do this out in the field to make sure that this was installed correctly. And I think I did mention it earlier. There's Economizers where this is already installed. There's actually no way for you to open it or close it. The only way is to send the signal, right? But just go ahead. One thing you can go ahead and do is on the actual Economizer controller, you can go to Setpoints. Actually, no, it's checkout. You can go to checkout. Okay, so we're in checkout, and then you're gonna go to damper open. Damper open. Press enter, and then press it again. and you see that actuator is going to open. So now we said it's a DC signal. So let's go and put it on volts DC, right? You can see it there. So if you recall, when I checked common and my red, that was 24 volts AC. But with DC signal, you can get the black lead and put it on the black one because that's still your common, right? My ground. And now we're gonna check the signal, the white wire. Remember, it's DC, so you gotta put it on DC, and it's gonna give us 10 volts DC. You see that? 10 volts DC, and you see the actual actuator opening all the way because it's receiving a 10 volts DC signal. So that is a test you want to do, a checkout test, to make sure that when it receives 10 volts DC, it's actually going to open all the way. So we're going to just let it run for a bit. What is important as well, if you look right here in the actuator, there's a little setting. You want to make sure the way we have it right now is we have it so that, and this, you see the little thing here, you can actually move it. I just moved it down. So now it's going to work backwards, but we don't want that. We want it so that when it's on this position, it's going to open clockwise, right? To the right. So, but yes, you can see by doing the checkout, you can confirm that it's installed correctly and then the wiring is correctly as well. Another cool test you can do, let's go ahead and get out of the checkout, right? So we're going to go ahead and let that just kind of default back. Another test you can do is you can get a 9-volt battery, and this is DC, and you can actually use a battery to test the voltage or to see if your actuator is working. So what you do, you go ahead and get the negative, right? The negative. Okay, so let's put this here. And my negative was my common, my ground. So I'm going to put it on the black one here. Okay, so that's there. Okay, and then now I'm going to get my positive, right? My positive, which is my 9 volts DC. And then, you know what, just so that we're gonna do that so that it's at in the close position, okay? And so this one here goes to my white wire, my DC signal. So let's go ahead and get that there. So you see, I'm actually simulating a DC signal because that battery is a source of 9 volts DC, and it's opening the actuator. So if you have a 9 volt battery, you can actually get it to open up. And we can confirm what kind of DC signal it's getting. Let's go ahead and check common and my signal. You see, it's getting a 9 volts DC. And then if you remember from that the whiteboard, at 9 volts DC, it's 87.5% open. So it's going to open almost to 90%. But yeah, by simply having a 9-volt battery, you can do a little test. Or simply by going to the checkout and damper open, you can also confirm that it's installed and all the wiring is correct. Okay, so now that hopefully you have a better understanding of how the actuator, the damper, the thermostat works, now we're going to focus on the actual controller. And before we get into the algorithm and the set points, look at a package unit. If you see a package unit, you have this package unit in front of you. The return is here, the supply is here, and you have your blower motor, right? So you have this air being pulled in from the occupied space, and your thermostat is down here, coming through here, going through the filter, the coil, and then it comes out as cold air going to my supply ducts, right? So with the system with an economizer, you have this other thing that's installed outside, which I will show you in a video where I go up on the roof. In a bit, I'll show you how that looks like. But the idea is that you're able to bring in some nice cold outside air in. Now, you have 2 dampers in a package unit with an economizer. You have the outside air damper and the return damper, and they work off each other. And so what I mean by that, let's say the outside air damper is completely closed, right? So let's just say it's 0% open, right? It's not open at all. This one's gonna be open, completely open. Let's say this one is 50% open, and guess what? That one's going to be 50% open as well. But let's say that this one is completely closed. Guess what this one's going to be like? That one's going to be 100% open. So they work off of each other. Now we also have to be able to read temperature. So we have these thermistors that are installed, right? So I pulled some thermistors from a mini split, but they come in different shapes and sizes. So this one, for example, you got like this special tubing. It's got a special element inside. But simply put, all you have is just a piece of metal with two wires coming out of it. And I'll show you how to read them when we go up into the roof. But you have two thermistors, right? Because we have to be able to read a temperature. A temperature of what? My outside air temperature sensor. So you have one of these thermistors outside. So you're able to see what temperature we have outside of the unit. And you also have one in the mixed air section. And why do they call it a mixed air temperature sensor? Why do we have one of these in the mixed air? Well, because you are getting some cold air coming in, or some air from the outside, and you have a return. It's a mix of the outside and the return. Many schools actually want you to have a minimum outside air damper open of 20%. So if it's 20%, this is 80% open. So you are getting that mix of outside air and return air. That's why they call it a mixed air sensor. Now, there's two things that you have to look at, and this is the set points that we actually have to mess with when dealing with the actual controller, at least in this case, the Jade controller. So there's a couple of things, okay? But we're just going to keep it simple. We're just going to worry about these two things, these two set points, boom and boom. So to have an economizer, let's say, working, right? We want to be in an economizer mode. We need to have first, we need to have a call for cooling, right? We need to have a call for cooling. Second, we need to understand what the dry bulb set point is, and then the mixed air temperature set point. This dry bulb set point, all it is let's say, for example, I put 70 degrees for my dry bulb set point. Okay, I'll repeat it. 70 degrees for my dry bulb set point. So let's say I use 70 degrees as my dry bulb set point, and my current outside air temperature, right? Because that's coming from my outdoor air sensor, right? That's getting the temperature from the thermistor. If it's reading 95 and I have a set point of 70, I am not gonna use an economizer. I'm not gonna be in an economizer mode, because I'm basically telling it, hey, if the air is below 70 degrees, go ahead. Let's get some economizer mode. Let's go ahead and bring some nice cold air into the occupied space. I wouldn't want to bring some 95 degree warm air coming from outside the space to the occupied space. It's too warm. My set point is 70. So if it's 70, anything above, I will not economize. If it's below, I will give it an okay, so I can do economizer mode. So, like, for example, if it's my set point remains 70 for my dry bulb set point, and it's reading 68 degrees, then yes, I am going to be in economizer mode, because I'm under the 70 degree set point. Now, this is one thing, right? That's just to tell the controller, the system, hey, you can do economizer mode, because yeah, we're below the set point. But another thing is to get that actuator to open up. And the actuator works off of this one here, your mixed air temperature set point. Mixed air temperature set point. And this is what you will actually see on the controller. So let's say, just for simplicity, let's just say my set point, right? My set point, and this is the one thing you can manipulate or change on the controller. My set point is 55 for the mixed air temperature set point. Now remember, this is my current value, right? This mixed air temperature sensor, it's reading the temperature and that mixed air compartment of your unit, right? Where it's getting some outside and return air. So let's say It's currently giving me 70 degrees. 70 degrees. And I'm telling the system, I want a set point of 55. Look for how far away I am from the set point. I want a set point of 55, and I'm currently reading 70 degrees. And this 70 degrees, remember, it's that return air coming up, so it's sensing how warm that occupied space is, right? That return air coming up. You're like, whoa, I'm 15 degrees away from the set point. You know what? It's kind of warm in the occupied space. I'm that far apart. You know what? Let's go ahead and open that actuator a lot because I'm really away from the set point. I'm 15 degrees. So let's say in this case, it gives it a 10 volts DC signal. So the actuator opens all the way because, hey, I'm far away from the set point. But let's say I put a set point of 66 and it's reading 70 degrees. You see, we're only 4 degrees away from the set point. I'll probably send, and this is just an example, maybe a 4 volts DC signal because I'm not that far away from the set point. I'm only 4 degrees. So the idea is the actuator will open more to bring down the mixed air sensor. The further away it is from the set point, it will open more to bring in that nice cold outside air in. Okay, I've been waiting for this moment finally to show you how it works. I had to explain everything to you guys because I feel like it's very important for you guys to understand how every single component works, how the set points work, the algorithm. I mean, I think it's very, very important. But the way I have this wired up, right, and we're going to actually show you how it's going to work off of the set points, and I'm able to actually manipulate the outside air temperature and the mixed air temperature as well because of the potentiometers. You probably won't be able to do this out in the field because these won't be installed. They're going to have thermistors, but just to show you, okay? I'm actually excited to show you this. So let's get a call for cooling. Okay, let's get a call for cooling. So there we go. My contactor pushed in, right? So I'm going to just go ahead and confirm, right? I'm going to go ahead and confirm we actually have 24 volts going to my contactor coil, right? So I'm going to put that on on VAC, volt alternating current. I'm going to go ahead and check my contactor coil, and you can see I'm getting 26 volts, okay? And one way to confirm that you actually are sending 24 volts out. So like I said, my R and my C here, that's my 24 volts powering up the controller. But let's go ahead and just check it, okay? So let's see if I can do it so you guys can see the actual, let's see if I can do that. Okay, there we go. So 24 volts there. But what you can do simply, remember what I said about Y1-I means? That's 24 volts coming in. I stands for in. And then my controller is going to be like, hey, you know what? I'm not in economizer mode. Yes, we need the compressor. Go ahead and go out. So what you can do, right, because this is 24 volts all the time, you can actually grab the comment, touch the comment here, check Y1 in, you see, 26 volts, and then check Y1 out. That should give you 26 volts too. If you have 0 volts here, that means that it's stuck. It's an economizer mode. So Y1 in, 24 volts, good. Y1 out, yeah, 24 volts. The economizer gave it permission for that to close the switch and then send the Y1 out to my contactor coil. But let's go ahead and manipulate it so it doesn't do that. And remember, I said there was 2 things we were gonna look at. There was 2 things. We're gonna look at mixed air, temperature set point and outdoor dry bulb set point. So let's go to set points right there, and let's put a mixed air temperature set point of 55 degrees, and then let's put a dry bulb set point of 70, which I already have it set up as. Okay, so I already have a mixed air temperature set point of 55 and then a dry bulb temperature set point of 70. So that means that my outdoor air temperature better be below 70 if I want the economizer to turn on. Okay, so let's go to status, right? And let's go ahead and check what our outside air temperature is. And we're reading 88.2 degrees. So remember our set point, our dry bulb set point was 70 degrees. So yeah, of course I'm not in economizer mode. I'm reading 88 degrees outside. That's warm air. You know, I told it 70 degrees and it's doing its job. If it's above 70 degrees, it is not going to be in economizer mode because I told it, if you're below 70, go ahead and turn on the economizer mode. But if you're above 70, I don't want that warm air coming in here. So economizer mode is off. And that is why I have the compressor, right? The contactor coil receiving 24 volts. The compressor's on. But let's say it is colder than 70 degrees. So I'm going to manipulate it using this potentiometer. And let's go below 70 degrees. I just heard the contactor coil disengage, right? The little yellow light is not turned on. And so how can we confirm that we're not sending 24 volts out? Well, you'll be able to hear it if the compressor's on or off, right? You'll be able to check the contactor coil. But another just more simple test, remember between R and C, that's always 24 volts. But then I'm going to check my C, use this as the kind of as a reference. And then Y1 in, you see that's going to be 24 volts. You can see it right there. I'm going to see if you can see it. There we go. My C and my Y1 in, 24 volts. And so when I check common and Y1 out, that should not give me any volts. And let's go ahead and confirm. You see, 0 volts. Y1 in, yep. But then when I check Y1 out, I don't have any volts because I'm in economizer mode. I am not sending 24 volts through this out to turn on the compressor because I want to save energy and because I have some cold air outside. I'm below 70 degrees. But how can I get this actuator to run? Because we said we need two things. My outdoor air temperature, which is the dry bulb set point, and my mixed air temperature set point. So if you recall, I gave it a, let's go ahead and confirm, a set point of mixed air temperature set point of 55 degrees, okay? Where are we at right now? What is my current mixed air temperature, right? What is it right now? The set point and the temperature are completely different. One is a set point, and then one is your current temperature reading, right? So my set point for mixed air temperature was set 55, but let's see what it is right now at this moment. You see, 55.6 degrees. So this is what I'm going to do. This is what's cool. As that increases, because let's say it is 60 degrees, this is looking at saying, hey, I got 60 degrees in that mixed air section. You know, most of it is going to be your return air. Like, hey, I'm a little warm. Let's go ahead and open up the actuator a bit. And look at me going to 60 degrees. 60 degrees, okay? Let's leave it there. And I'm going to get my meter and put it on DC. Okay, so let's put it to, there we go, 63. Give it a second. Okay. There we go. You see that opening? It's opening because I'm from 55 was my set point. 63, that's, what is it? 8 degrees away. Look, it's opening that outside air damper. And I can confirm by going down here. Let's check how much DC signal is sending out. I am getting 3 volts DC. Sorry, let me just go ahead and flip that. 3 volts DC. Okay, there we go. 3 volts DC. Look, this is what I want you to understand though, right here. My set point is still 55 degrees, right? Let's say it's really hot. Let's say let's just give it 70 degrees. Or even much more. Look at my DC signal increase to open the outside air damper more to bring in more cold air in. You see, I am increasing the mixed air temperature because I have a really hot house, hot room, hot classroom. So it's going to increase the DC signal going to my actuator, opening the outside air damper more. And it's going to get to the point where it's 100% outside air damper completely open, my return air damper completely closed. So the greater this current mixed air temperature sensor the reading, the actual temperature reading, right? Because it's really hot in there. The greater that is from the set point, the more it's going to send a DC signal. And obviously the max of it is 10 volts DC, but it's going to open it all the way so it can bring that temperature down. So right now, let's give it a second. You see that's climbing up because I'm reading 100 degrees in that mixed air section of that unit, 100 degrees. So it's pretty warm inside. But you see it's going to get to the point where it's going to max out at 10 volts DC. And we can confirm, look at that, it's open all the way. And so now you're like, okay, well, I know that it's open all the way. I know that it's open all the way. And so if my return air damper is completely closed and my outside air damper is completely open, well, now I'm not really reading any return air going up. How do I know it's going to shut it off? Well, in the meantime, it is bringing in all that 100% outside air in coming in. It is cooling the house, right? It's going through the outside air to my supply. So it's going to get to the point where your thermostat is going to satisfy and you're not going to have a call for cooling. And look, everything's going to reset. So I just turn off the call for cooling and look at everything now reset. That's going to close all the way. And if this closes, my outside air damper, my return damper is going to open completely open. So you see, it is always looking at your dry bulb set point and at your mixed air temperature set point. Yes, you need to have thermistors. You need to have thermistors so it can read temperature. But it's always looking at those two things and also with the call for cooling to be able to use the economizer mode. One of the students asked me something very interesting, and it got me thinking. But it makes sense. But how do you know when to turn off the economizer? Because remember, it's looking at the mixed air temperature sensor to then drive that actuator open a lot more open or closer. How does it know when to shut off the economizer? Well, have in mind, you have a call for cooling, right? This whole time you have a call for cooling because the occupied space is warm, right? It's a little warm. So let's say it's 100% open and then my damper, my return damper is completely closed. It's 0% open or 100% closed, okay? Let's just say it's 100% closed, 100% open. So it's bringing in all this air in, right? So of course, this is going to be dropping in temperature, right? Because it's not really reading your conditioned space anymore. It's not really reading the return air space. But what is down here? Down here in the occupied space, you have your T-stat, your thermostat. So once you bring all that cold air in, it's going to satisfy the thermostat. And so once it satisfies it, you're not going to have a call for cooling anymore, and then it's going to shut off the economizer. But you can get pretty advanced with the controller because have in mind, since you're bringing outside air in, you can think of air as water. You're bringing this outside air in. You're not recirculating it. So you're basically bringing in some mass, some volume, some water inside, or in this case, air. And so you have a positive pressure building. So you got doors opening, swinging open. So a lot of the times they'll use this Jade controller, and it actually has the capability to then, if you're bringing in outside air in, to turn on an exhaust fan to keep that balance within the building. Okay, so this is a package unit, and this is the control board. This is the thermostat wire coming up here. So instead of calling for cooling from the bottom, I'm just going to jump right from here so I don't have to go down there. But this is the mixed air temperature sensor. And so this is the one that's measuring your return and your outside air coming in. We'll go a little bit more into that right now. But this is my economizer, right? And you'll be able to see it if you go to a unit. It kind of looks like that, right? And inside you have your actuator, right? We already kind of have gone over a couple of things, right? My 24 volts, and then my 2 to 10 volts DC signal coming in. My thermistor, right? And thermistors come in different shapes and sizes, but this Honeywell, this is kind of how they look. And then with these, they're not that difficult to test. In fact, it's kind of funny. It says outdoor air sensor error because where's the wire right here? I pulled it out. But if you want to make sure the thermistor's reading correctly, you can actually see 2 pins coming out. So because I only have 2 hands, I did get 1 lead going to one end of the alligator clip, and then I put it on ohms. You have to make sure you can read in the thousands of ohms, at least the K. And you can see right there, that one right now is on millions, but you should be able to read in thousands of ohms. So, and most meters have that, but I put it on ohms. I should not see open line, right? I'm getting a reading. Good, 33, CK, 33,000 ohms. So I'm getting a reading, so it's good. So let's go ahead and plug it back in. But this is what I'm gonna do, and I did it in the earlier video. You're gonna see that clear out. You see the error cleared out. So let's say we go to, let's say checkout, okay? Let's go to checkout. Okay, and then let's go to damper open. Okay, I'm gonna open that. Have in mind, my outside air damper is currently closed. And then if I come here, this is my return air right here. This is my return air, right? So my return, you can see down there, I'm able to actually, let's see if I can get, you see down there, I'm able to actually put my hand in there. That's the return air coming up here, going through the filter, going through the coil, and then coming down on the supply. But because I am basically, I just told the damper, hey, go ahead and open up completely. It's gonna close my return completely, and you'll see it right now. This is what I mean. It's gonna close this completely, and so if this is closed, that's gonna be 100% open. And you just have to be patient. It does take a little while for it to open all the way, but you see now I'm able to see some, I'm able to actually put my hand through, and so outside air is gonna come in. So you see right about, almost right about in a bit, the return air is going to be completely open. The outside air is going to be completely, the return air is going to be completely closed. The outside air damper is going to be completely open. They work off of each other. So you see right now, the return air damper, bye-bye, that's it. And look at my outside air damper, completely open. So I'm going to go back here. You see, now it's open all the way. So it's sending 10 volts DC signal, right? And you do it by checking the common, the ground, and this and the signal. You got to put your meter on DC and 10 volts DC signal. So I'm gonna go ahead and get out of the checkout. You see, it's gonna default back. So now that's gonna close completely, and you can see it right now. It's closing. You can hear it. It's closing completely. Give it a couple seconds. You see, it is closing. And as the outside air damper closes, my return air damper opens. Okay, so going back to the basics, right? We're just gonna worry about 2 things: the dry bulb set point and your mixed air temperature set point. So let's go to set points. And so, and you know, you have so many other things here in this controller. You can actually tell it like a lot of things. Like for example, system setup. You can tell it if you want to use Fahrenheit or Celsius, if it's a heat pump or conventional, right? You can also, you know, there's so many settings to this, but like I said, we're just gonna keep it simple. So set points. So my mixed air temperature set point is 55, and my at a dry bulb set point is 70. So if I am below 70 degrees, I'm gonna turn on the economizer, and I believe I am, which we'll check right now. But dry bulb set point 70, and mixed air temperature set point is 55. Okay, so let's see what we're currently reading right now. We are reading, so we set our dry bulb set point is 70, and right now we're reading 57 degrees. So right now it is 57 degrees. So if I have a call for cooling, I'm gonna have the economizer mode on because I'm below 70 degrees. And so then now let's go to the mixed air temperature, my current one. So that 57 degrees, it's coming from here. It's reading 57 degrees. So obviously I opened it. So obviously it's not gonna be accurate, but the mixed air is coming from in there. The outdoor air sensor temperature is coming from here. So now if I have a call for cooling, let's go ahead and just, you know, this is a, like I said, just for simplicity, this is a conventional system, right? Let's go ahead and call for cooling. Okay, I jumpered R and Y, right? R and Y. So look what it says here. I jumpered R and Y. Let's go to status. You see economizing, yes. So my 24 volts is stuck right there. It's not going to the contactor coil, but that hasn't opened up because it's looking at your mixed air temperature set point, which we said it was 55. And then my mixed air temperature, my current mixed air temperature is 57. So look what happens when I do this. Let's go to the set point. Okay, so we said it was 57 degrees. It's currently reading 57 degrees in the mixed air temperature section. Let's drop it down to 47. I want more air coming in, more air, because you know what? I'm too close to the set point. It is not gonna drive that actuator open. So I'm gonna go to all the way down to, let's say, the set point. I want a lot of cold air to come in. Boom, 48. And watch that now open up very little. Now you have to be patient, but you'll hear it right now open up. So it's gonna send a little bit of a DC signal right now to open up, and you can see it right there. You're able to hear it, not too much. There we go. Let's see. You see that? It's opening barely, but it's opening, right? So it's sending the signal so it can open because I put a set point of 55. I put a set point of 48, and it's currently reading 57 degrees. So I was like, okay, open up, because I want more cold air to come in. So yes, it's a lot going on, but just going back to two things: dry bulb set point and mixed air temperature set point. You got your actuator, you got your thermistors that are reading your temperature, and they go wired up right here on the top portion here. And then you got your controller. And the controller, you do have to set it up if it's conventional or if it's a heat pump. So let's do a quick recap. Economizer simply means free cooling. If I have a call for cooling, because it is possible that even though it's cold outside, inside I might have 30 kids and I might be warm. So it is possible that even though it's cold outside, I could have a call for cooling inside. And if that's the case, instead of turning on the compressor, right, which is what gets the cooling going, right, pumps the refrigerant, instead of turning on the compressor, the controller will stop the 24 volts from leaving out to the contactor coil, and it will open up the outside air damper so I can bring in some of that cold outside air in. So it's looking at two things once again, right? It's looking at my dry bulb set point, which is something that we as technicians can manipulate, right? And you were able to see how when having it at 70 degrees and it was reading, in this case, an outside air temperature of 95, I was not going to bring in 95-degree air. I'm not going to have economizer mode. But if I have a set point of 70 and I was reading on my thermistor, right, which is my outdoor air sensor, 68 degrees, because I'm below the set point of 70, hey, go ahead, bring some nice 68-degree outside air in. But to be able to drive that actuator is looking at your mixed air temperature set point, because have in mind that return air coming and your mixed air temperature is in that little area where your outside and your return meet. It's going to be looking at how far away you are from that set point. So if I have a set point of 55 and the mixed air temperature sensor is reading 70, man, I'm 15 degrees away. Go ahead and open that actuator, open it all the way, bring that all that cold air, because it's really warm in here. But if I'm maybe 4 degrees away, maybe you'll send just a small DC signal to that actuator. So yes, it's looking at a couple of things. It's looking at the dry bulb set point, your mixed air temperature set point, and if you have a call for cooling. And also important to make sure to install those actuators correctly, wire them correctly, and you'll be able to get some free cooling in your next service call. I hope this video helps, and I will catch you on the next one.